All right, Java array lists is going to be our next topic. We've already dealt with arrays, and as we define them, there's a few things about arrays that makes them very limited in their use. Main one being this. It's Google declare Java array. We can declare Java arrays a couple of times. A couple of ways, rather. One way to declare them is to declare them with a certain number of elements. That would be done here. This is declaring a string array that's going to contain 3 elements. Another way is to declare it this way, where you specify in curly braces the list of elements in the array, 1, 2, 3, 4, 5, and that becomes the size of the array. So far, so good. Now, the thing about these is when an array is declared, it stays at the size it was declared at. So this array right here is going to have 5 elements in it. The only way you could add a 6th element is if you change the code and recompiled it. You can't on the fly add a 6th element to this. Likewise, this array up here contains 3 elements, name 0, 1, and 2. It's only going to contain 3 elements, and it's always going to contain 3 elements. And if you think about that, that's a big limitation. Let's think of some examples of where you have a list of items, and let's try to decide if they're a fixed size or a variable size. What about the number of courses that a faculty member teaches? Is that a fixed number or does it vary? Well, it varies. One faculty person might teach 4 classes, one might teach 6. I might teach 6 courses one semester and 7 courses the next. So it varies, the size varies. So therefore, if I was building an application, I could not use an array to hold the courses that a faculty member teaches because we don't know how many they teach. Now, you might think, well, couldn't we just declare a giant array? Well, that's wasteful for a lot of reasons. Couldn't we declare a 100-element array? Well, that's really kind of a waste to do it that way, and it could create some very confusing code. It's much better if we could allow the list to expand and contract. So for example, let's say we're planning spring semester schedule, and I'm slated to teach 6 courses. And a new section of CISS226 is added, and therefore it's added to my workload. All right, my list then would have 7 elements in it. Let's say a class is canceled. So, okay, so I'm back to 6, and so on and so forth. So that would be an example of where there'd be a variable number of classes associated with each professor. So an array wouldn't work. All right. What about number of pizzas on an order? Is there a fixed number of pizzas on an order? No. I called yesterday and ordered 1 pizza. When I'm with my friends, we may order 3 pizzas. If I was having a party, maybe I would order 8 pizzas. All right, so the number of pizzas that I would order, that I put on an order, would vary. There's no typical order that it would have 2 pizzas on the order or 5, and always have that number. And if you think about this, number of students in a class, well, that varies. Some classes have 10, some classes have 20. Pretty much anything that you think of in a real life environment. Contestants in a local marathon. The list of contestants, would that be an array or an array list? It would be an array list. It depends on how many people sign up. It could not be an array then. And therefore, you'd have to use the alternative that I've hinted at, and that is an array list. All right. There's 2 key things to remember about array lists. And we'll get to the implication of one of them later on. So the first thing that is key to an array list is that size is variable. It can be expanded or contracted based on the needs. Second thing is an array list can only hold objects, specifically object reference variables. That turns out to not be that big of a restriction, but we'll talk about that in probably around the end of class. But just sort of keep those 2 restrictions or 2 characteristics in the back of your mind. That's the big thing that an array list has that an array doesn't. I'm going to show you the tutorial, and there's a couple videos that you can watch on your own time. Remember, this being a blended class, you can, in addition to the material I cover in class lectures, there's material available online that you are expected to look at and read. Couple of things about array lists. This is how you would declare one. First of all, you have to tell the Java compiler that you're going to be using the array list. And I don't think we've had an example of any of these because our Java programs have been pretty basic up to this point. But the way that you tell Java that we are going to use the Java array list is by putting an import statement. That points the compiler to where the array list class lives. So we have to import any classes that aren't built, that aren't just based on the basic Java framework. So that needs to be in front of all of your programs that use an array list. This is how we declare it. We say array list string, give it a name, equals new array list string with parentheses, an empty constructor. This designates the type of data that we're going to be storing in the array list. So in this particular case, cars, each member of this array cars is going to be a string. Each member of this array list cars is going to be a string. So this declares that that is the case, and this creates the array list and tells it again that it's going to contain string. Now, how do you add things to an array list? You add things to an array list by using add. So I say the name of the array list dot add, and I put in parentheses the name of the object that I want to add to the array list. So this would add the string object Volvo. The next one adds a string object BMW. The third one adds a string object Ford, and finally Mazda. Now, a nice thing about this is this website is that you can do these tutorials interactively. So when you click the try it yourself button, if you run this, it shows you the output. Might take a minute, but there we go. If we print out cars, it will tell us that's the member of the array list. And we can then go and add another item to the list without having to change the declaration of the array list. There's two ways that you can loop through an array list. One is by looping through each individual element using a for loop that loops through each of the occurrences in the array list, like this. I can declare a variable, we'll call it I. We're going to do this as long as I is less than cars.size. That's how we tell the size of an array list. And each time through the loop, we increment I by 1. And we can output ours. We don't use the square brackets, but we say get I. So get is what we use to retrieve elements from an array list. Run this and right there. Oh, and I equals 0, my mistake. And there they are. Right? So we can add members and we can loop through them. There's a different syntax for looping through an array list. I always forget this for some reason. So I have a note to myself in the lecture using the for each. So I can say for each string in cars, so for each thing in this array list, which of course we know is a string, we can output that string. And that'll give us the same results. Doesn't matter which you use, you can use either one, whichever one you find easier, more convenient, whatever. That would be how you can loop through elements in a Java list, a Java's array list. What are other things that we can do? We're going to look at the Java docs. And Java docs are the official Java documentation for an array list. And this shows us a number of things about it. It shows what constructors are available. There's an empty constructor that creates an empty array list with an initial capacity of 10. So that size can change, but initially the capacity, it reserves that much memory for it. We could actually create an array list from an array if we wanted to, or some other kind of collection. Actually not an array, but some other kind of collection. Or we can initialize the initial capacity. All right. We're typically going to be using the empty constructor for this because we just want to create a basic array list. We can add at a particular index. So let's go over here. And let's say add Toyota at position 0. It's going to put Toyota on the top of the list and bump everything down. Normally, when you add and you don't specify the position, it puts it in the highest position in the array list. But you can specify where you want to put something in the array list by doing that. You can clear to get rid of that. You can check to see if a particular object is in the array list. You can loop through. We looked at that already. We can get by specifying the index. We can give it an object and it will tell it what position it's in. So if I said index of Toyota, it would tell me it's in position 0. It will tell us if it's empty. And finally, we can remove the object, either by giving the object that we want to remove or the index. So I could say, ours remove 1. Bars remove BMW. Think in your head what this is going to do. See if you can determine what it's going to look like. I think it's going to say Toyota, Ford, and Mazda. Let's see if I'm right. I'm going to be right as soon as I remember proper syntax and put the semicolon. Toyota, Ford, Mazda. Why is that? Well, I added them, except I added Toyota at the beginning. So my list at this point is Toyota, Volvo, BMW, Ford, Mazda. I remove element 1, that removes Volvo. Then I remove the element BMW. So that leaves us with Toyota, Ford, and Mazda. Go through this tutorial. This shows you how you can do a lot of things with this. You can modify an element by using the set command. Remove an element, clear everything, get the size of the array, loop through it. Again, I showed the 2 different ways that you can loop through it. You can sort an array list. Doing this, that will put it in alphabetical order. And so on. All right, let's look at this with our pizza example. And with our pizza example, what I did is I created a new class for orders. So I have my unit test class. I have my pizza class. I now have my orders class. Pizza class, we actually do not need to change anything. This might look like what we had last week. It might be a little different because I think this is from another semester, but we have our constructors. That we have 3 different constructors, which we're allowed to have if we give 3 arguments it assumes the first one's a string, the second one's a string, and the third is Boolean, and it stores them in size, crust, and pepperoni. The second one, if we give two strings, it defaults. The first one is the size, the second one is the crust, and has pepperoni is defaulted to false. With this one, we only give it a size, and that's whatever argument we give it. The default is thin crust, and the default is has pepperoni, is false. We have all our set and get methods. We calculate the bake time. We calculate the price based on this rule. If the size is S, our base price is $8, 10 and 12, an extra $1 for thick crust, an extra $2 if we have pepperoni on it, and then we turn the price. So we didn't do anything to this class. This class was correct the way it was. There's no need to add it just because we're going to be adding it to an order. Now, the order class is the one that we create. Now, if you think of an order, and again, think in real world terms. Sometimes we get very close to a programming situation and we can only think in programming terms. But just think logically. What does an order consist of? Well, if you order a pizza, it's going to consist of your name, right? It's going to consist probably of your phone number. Maybe it will have your address in it if it's a delivery order. Then it's going to have a list of pizzas that you order. Now, how many pizzas are you going to order? I don't know. It depends how hungry you are or how many people there are that'll be dining with you. So the list of pizzas is going to be a variable size. So we can't use an array for that. We're instead going to use an array list. So let's look at the attributes in our order class. I went the easy way and I just declared a name and a phone number. But I did declare an array list of pizzas. That means I can only put pizzas in this array list. Now, if my pizza shop also sold sandwiches or salads or something like that, I couldn't do it like this. I would have to change, I would have to do something else. That will get into inheritance, which is like later on in the semester. But right now we're going to restrict our pizza shop to only selling pizzas. So this is valid. We have an array list of pizzas, meaning that we have as many as we have. Virtually unlimited. It's going to start out with a capacity of 10. That's just the memory that it allocates. And there'll be actually no pizzas in that list. All right, we could create a constructor for our order class where we accept the name and the phone number, initialize those attributes. We have our sets and gets. Then we have an add pizza method. Notice what that does. We're going to be adding a pizza to the pizzas array list. So we need the argument to be a pizza. Because pizzas, we're not going to add a string to the array list. We're not going to add a number to the array list. We're going to add a whole pizza object. Because pizzas are how we the pizza class is how we represent a pizza in our application. So therefore, the argument that we're adding to the order is going to be a pizza, a single pizza. How do we add it? Well, we use ArrayList.add, and we add our argument to it. This, of course, has to match this. Because we said that we're putting pizzas in this array list up here. So when we get around to putting things in the array list, they better be pizza objects. I then have two methods on the pizza class, or I'm sorry, on the order class that are pretty similar to the ones on the order class. I have a calculate bake time. Now this is assuming that I have a big pizza oven and I can bake these pizzas all at the same time. So if I order two pizzas and I can bake them at the same time, the total bake time for the order isn't the sum of the bake times, right? So if I have a thick crust that takes 16 minutes and a thin crust that takes 10 minutes, my total bake time for the order, assuming that we're going to bake those at the same time, is not 26. It's not the sum of the bake times for the individual pizzas. It's actually the maximum of the bake times for the respective pizzas, right? Because I put the two pizzas in, the thick and thin, at the same time, 10 minutes elapse, thin crust can come out, 6 more minutes, the thick crust could come out. So the total bake time was 16 minutes for that particular pizza, for that particular order. So it's the maximum. Now, again, this makes the assumption that I can always start my pizzas at the same time. That may or may not be a good assumption, but we're going to assume that. We're going to assume we have a really big oven, and therefore we don't have to wait for one pizza to be done to start the second pizza. All right, so what does this code do? We initialize bake time as 0. This is going to return a double. In other words, it's going to return a double that contains the number of minutes that this order needs to bake. We're going to loop through the list of pizzas. We're going to start with I equal to 0. We're going to go through for as long as there are items in the pizza list, array list. So for example, if there were 2 pizzas, there would be, the size of that array list would be 2. And we'd run the loop one time with I equal to 0, and we'd run the loop a second time with I equal to 1. That's what this means. We're going to do this as long as I is less than the size of the pizza. And the size of the pizza, or the size of the pizza's array list. So this is going to be 2 if there's 2 pizzas on the list. So I equals 0, I equals 1. And that's the exact subscript that we're going to use for each of these. The first pizza is going to have a number of 0. The second one's going to have a number of 1. And we increment I by 1 each time through the list. So what we do is we get that pizza. We declare pizza P equals get the pizza. Notice there's no new in this statement. So I'm not creating a new object. I'm referring to another object. So I'm referring to the first pizza in the array list the first time through this loop. And if the bake time for that pizza is greater than the bake time that we have so far, then the bake time equals that pizza's bake time. We do this for each pizza, and by the time we're done, we have the maximum bake time of all the pizzas on the order, and we return that. Now the price is a little bit different, right? The price, we do add up the prices. So in other words, how much does a order cost? Well, you add up the amount, you add up the price for each of the pizzas. And that's exactly what this does. We set our variable for price equal to 0. We're going to do the same thing. We're going to loop through all the pizzas in the array list. So if the size is 2, we're going to do this with I equals 0 and I equals 1. We're going to get that pizza on the list, and we're going to add that pizza's price to the order's price. And when we're done, our sub is going to be in the variable price, and we can return that. Okay, let's look at our unit test. Now, before we do that, a couple of things, because I graded over the weekend, and you're expected to follow the model of these class examples. In other words, you are to have a unit test class along with your regular business classes. We'll call them business classes. The classes that are actually doing the work. The unit test is the only one that you can really hard code particular values in. Because remember, the unit test is taking the place of a GUI, which will be in place later on. In other words, later on, we're going to have a GUI that's attached to this, and we're going to click on checkboxes or click on radio buttons and drop downs to pick the parameters for a pizza. Then we're going to click add to the order, and that pizza object will be created and added to the array list for the order. But right now, we don't have that GUI yet. We haven't studied GUIs, but we can still develop these classes by creating a unit test. So always you're going to have a unit test and the other objects for your problem. Each file should only contain one class. We'll come into a couple exceptions of this very late in the course, but for now, one file, one source file per class. So I have a test. Now, this isn't a thorough test. It was one of the other things I noticed. A lot of you, for your student calculation, you only tested a couple of different possibilities for the student. That's not complete, all right? Because you could get in-county student calculation correct and have the out-of-county or out-of-state incorrect. Or you could get for 1 to 12 credit hours correct, but not 13 through 18 credit hours correct. Or you could get those two correct and not have 19 and above correct. That's what many of you had issues with. The point is you need to test to make sure you have every possibility covered. So in this case, I would say you need a minimum of 9 test cases. And you could argue for more, but at the very least 9. You need in-county, out-of-county, out-of-state. For each of those 3, you'd need 12 hours or less, 13 through 18 hours, and 19 and above. So you need 3 different students for the 3 different classes, and that's where I got the 9 from. So here I'm creating pizzas. At this point, I'm just creating the pizza classes using the constructors. So I default the first one size to S, the crust to thick. I set those via the constructor. The has pepperoni is set to false because that's what my pizza constructor does if I only give it 2 arguments. Do the same with the next pizza, except I set the size to large. It's going to set the crust to thin, and it's going to set has pepperoni to no. So this code from here to here is just testing to make sure that the pizza logic is correct. Now you may say, well, I already tested the pizza object. You need to test it again. All right, every time you make a change, you should test thoroughly to make sure you have not introduced any new problems into the solution. That's sometimes called regression testing. In other words, did you break something that used to work? Did your application regress to an error state? Notice how I spent a little bit of time formatting the output. Not saying this is going to produce pretty output, but it's going to produce output that is readable and understandable, that I could show to someone and they could look and say, yeah, that's a correct calculation, or no, it isn't. If you simply have an output that shows $2,362. And you don't say what that's for. Someone looking at that will say, okay, that's a number, all right, but so what? Is that the correct number? Well, in the case of the student, you would want to output how many credit hours the student had, what their residency status was, and then their tuition, and have each of those things clearly labeled. All right, then I have my order class. So I create these pizzas individually, and I test the pizza class individually, and then I go and I add to the order the first pizza, add to the order the second pizza, and then say the cost of the order, which should be the sum of the prices, and the bake time. So the bake time should be 16 minutes. The cost of the order should be small would be 8, large would be 12, but thick crust should be $21 if my math is correct. Let's see if I got that right. I don't remember. I called the folder, so I'll do a dir. It's called WED1. No, actually, I call it example. Here's where my code lives. I'm going to compile it. Java C, star.java. Compiled it. It did not report any errors. Now, when I run this, I'm always going to run the unit test. The unit test is the one that has the main method, right? Because this is sort of the boss of my other classes. It's going to take the place of the user interface. So it's going to create everything and call the methods to get the results. First one's small, thick crust. Oh, I didn't realize that was thick. I did. So I think my answer is going to be right still, but I added up the individuals wrong. This one's going to be $9, bake time of 16 minutes. This one's going to have a bake time of 10 minutes and a cost of $12. The sum of these two is $21. The bake time is 16 minutes. Go over these examples. There are parallels between the examples I do and the assignments that you're given. If you take the time to watch the lectures and review the examples. So how does this relate to your homework assignment? Well, in your assignment, you have students, and I've asked you to get rid of the attribute for students and put in, create a new class. Talk about your lab for this due next week. So you're going to create a course class with these attributes, with the constructors, the get and set. You're going to add an array list of courses to the student class. In other words, courses is going to be like the pizza class, and student is going to be like the order class. The student class will have an array list of courses in it, just like the order class has an array list of pizzas in it. You'll add a method to add a course to the student's list. You eliminate what you did before for credit hours. That is, you had an attribute that you could set and get and display use in calculations. And you're going to replace that to use the total of a student's credit hours. So you'll need to loop through the array list, look at each course, get the credit hours, and add those up. Document how you are going to test this with a test plan. Put in a separate document. Test case is a specification of the inputs, testing procedure, and accepted results. So one of your test cases might be, I'm going to create a student that's in county that has one course, CISS226, that is 3 credit hours. My expected results would be that the total credit hours for that student would be 3. And the tuition for that student would be $159.03. Another test case might be, I'm going to create a Lorain County resident that's taking 4 courses, each one 4 credit hours. And my expected result is that the tuition is $2,067.39, and so on. You need to document what your test cases are. Because if I went back later and changed some of the code, I would want to go back to your test plan and retest to make sure I didn't break something. All right. Maybe modify it depending on what changes I made. Maybe I would have to add some test cases if I added maybe a 4th category. Okay, last thing. Remember I said a while ago that an array list can only contain objects. So we've seen an array list that contains strings. We've seen an array list that contains pizzas. What about numbers? Can we create an array list that contains ints? And the short answer to that question is no, we can't. But there's a real quick workaround. And that gets into the topic of boxing and unboxing. So every primitive has an object version. So we have an int, which is a primitive for integer. And there's an integer, there's an object version of the int, which is called integer. And notice it's an object because it's a capital I. It's a class and object. And boxing and unboxing automatically converts the primitive to the object. So if I say add 33, that's actually a primitive int, but because of boxing, that automatically converts it to an integer object. And again, string in Java is not a primitive type. To use types such as int or other primitives, you have those are called wrapper classes. Integer is for ints. For Boolean, you use Boolean with a capital B. Character for char, double for double, and so on. And here's a list of all the wrapper classes. In other words, all the primitives have a object version, which is called a wrapper class. And these are what's used if you create an array list. So that's not valid. This is valid. And we can create, the conversion is automatically done. If I say my int equals this, I don't have to say equals new integer and then give it a value. I could, but I could just as well set the value as though it were a primitive. So these wrapper classes sort of give you the best of both worlds. They're objects, so you can put them in array lists, yet you can kind of treat them like they're primitives. And that process of treating them like they're primitives, of making an object out of, and then making a primitive out of, is called boxing and unboxing. All right, I want to encourage you to ask questions if you have difficulty. I had a number of students that turned in assignments that were not complete and were not correct, and they put a note in the comments of their submission that said, I couldn't get this to work, or I couldn't get that to work. I want to refer you to this announcement that I made. If you're getting compile errors or other issues preventing you, don't turn it in. Email me the question and include the code, of course, and I'll answer it, or we can set up an online meeting. If you turn in code that I can't run, you'll get a 0. Because if I can't compile it and run it, I'm not going to take the time to figure out what's wrong. That's your job as a developer. All right? So don't turn it in just to have something to turn in. I'd rather you spend an extra day or two and ask me questions and get the answers and come up with the correct solution. So only turn it in if you think it's correct. Secondly, if you ask a question, I'm not going to flat out necessarily going to give you one simple answer that will solve your problem. I might ask you a question in return that I hope will point you to the correct answer. These skills that you're developing in this and other programming classes, being able to reason things out and troubleshoot and that kind of thing, is a skill that is important to have, and it's important to develop, and it's important to practice. All right? Therefore, I want you to practice them here. And if you are having trouble with something, in addition to you getting the correct answer, I want you to understand the thought process of how to get that correct answer a little bit better. All right, are there any questions? All right, if there are no questions, I'm going to be headed to lab. I'll either see you in lab or I will see you next week. Take care.